Remember that Genexus determines the base table of the forEach command, taking into account the name of the transaction that we declare next to the forEach command, which corresponds to the name of the base transaction, that is, the transaction whose associated physical table we want to run through. In addition, the attributes declared within the forEach command, whether in print blocks, where and order clauses, and so on, must belong to the extended table of the forEach command's base table. In this example here, the base table of the forEach command will be attraction, that is, the table that will be run through and whose extended table will be accessed in order to retrieve the required data. The navigation list clearly says that the base table is attraction, which will be run through according to the primary key of that table, that is, ordered by attraction ID, and that the entire table will be run through, also accessing the country table to retrieve the country name value, which corresponds to the country of the attraction. So, is it mandatory to specify a base transaction for a forEach command? The answer is no. Genexus can calculate the base table of the forEach command from the attributes included in the command. The way to find the base table will not be seen in this course. Let's now move on to the indexes and their relationship with the database queries. We already know that indexes are efficient ways to access data. We've already seen that, in each table, Genexus creates an index by the primary attribute, either a simple or compound key, and an index by each foreign key. This is done to make data consistency controls between tables more efficient. We also saw that it's possible to define indexes, indicating whether they accept duplicate values or not. If we define an index that does not accept duplicate values, that is, a unique index, we're telling Genexus that it must automatically control the uniqueness of its value, and that attribute, or set of attributes over which the index is defined, becomes a candidate key. If we add an order clause, for example, to order by the name of the attraction, the navigation list gives us a warning, informing us that the database has no index by the attribute by which we need to order the information. So this query could have low performance. When we give Genexus an attribute by which to order data, it tries to order it in an efficient way. Therefore, it looks for an index by that attribute. But since it can't find it, it informs us about it. If we need to obtain the records of attraction ordered by the attraction name attribute, these records will have to be reordered, because by default, they're ordered by the value of the attribute that is the primary key. When a query is defined, if there's a physical index created in the table for the attribute to order by, Genexus will use it. In this case, the query has to be ordered by a secondary attribute, attraction name. Genexus warns us in the navigation list, as we've seen, that an index hasn't been created. The existence of an index would optimize the query. However, the disadvantage of creating an index is that it must be maintained. That is, as users add, modify, and delete attractions from the attraction table, this index must be rearranged. Once we've done this, the database will be reorganized by pressing F5 to create this new index. Then, in the navigation list, we'll see that Genexus will use that index that has just been created. It's worth mentioning that just as we create it, at any time we can delete an index, and by pressing F5 and reorganizing, we'll return to the previous status. Let's see this example. Suppose we want to get a list of attractions whose names are in alphabetical order between a couple of values received by parameter. For example, between the letters B and N. That's why we specify the where clauses we're looking at. Having several where clauses is the equivalent to having only one, where the conditions are combined with the AND logical operator. In other words, only records that meet all the conditions at once will be considered. If we're going to filter by attraction name, and we have an index created by that attribute, we should always order by attraction name to optimize the query. Note that if we don't enter the order clause, Genexus will order by primary key, and the entire table will have to be run through to know if an attraction is within the specified range or not. Okay, let's now see the when clause that will allow us to condition when to apply orders and filters. What result will be obtained for the for each command we're looking at if the name from and name to variables are empty? If there were an attraction with an empty name, then it would be the only one returned, since it would be the only one that would meet the conditions. Otherwise, no attractions would be listed. Is it possible, then, to consider the orderings and filters so that they're only applied in certain circumstances? For example, to only apply the first where clause when the name from variable is not empty, and to only apply the second where clause when the name from variable is not empty? The answer is yes. We achieve this by conditioning the where clauses with when. Each where clause will only be applied when the when condition is met. In this way, at runtime, when we leave both variables empty, none of the where clauses will be applied, so all the attractions of the table will be listed. If the name from variable is empty, but name to is not, the first where clause will not be applied, but the second one will be. So all attractions whose name is lower than or equal to name to will be listed. In the same way, you can set conditions for applying an order or not. In fact, a series of conditional orders can be specified in order to choose the first one whose condition is met. Let's now move on to the when none clause. What happens when none of the records in the base table meets the conditions indicated? Let's suppose that in this case, we want to print a warning message on the output saying that there are no associated records. To this end, we'll program the when none clause. All commands written between when none and n4 will be executed sequentially, and only when no records from the base table of the for each command have been found that meet the conditions indicated. In this example, we've decided to print a message, but we may also type a series of commands, such as another for each command, for example. Since what will be executed after the when none clause will imply that the search was unsuccessful, if we type a for each command there, the when none clause will not be nested. It'll be like a standalone for each command. In summary, as we've seen, the base table of a for each command is determined from the specified base transaction. The rest of the attributes mentioned, both in the body of the for each command, main code, and in the order and where clauses, must belong to the extended table of that base table. The attributes mentioned in the when none block will not be taken into account. We gray out everything we've seen before. Here, we've added the when and when none clauses. Later on, we'll see that more clauses can be added to this essential command to access the database. Finally, let's examine a case study. Let's consider the following transaction design: the customer transaction, the trip transaction corresponding to the trips with a tour guide in charge, the tourist guide transaction with its set of phone numbers, and the reservation transaction to record, for each customer, the set of trips that he or she has booked. We need to obtain a list showing, for a given customer, and from a given date, all the trips he's booked, and for each of them, the contact phone numbers of the tour guide in charge. To solve this, we propose the following source. Let's examine if the information listed is the one we're asked for. There's a couple of nested for each commands. In the first one, we explicitly say that the base table will be the one corresponding to the trip level of the reservation transaction, that is to say, the one called reservation trip. We confirm that, within that external for each command, no attribute is being used that doesn't belong to the extended table of reservation trip. If so, the navigation list will show a warning that this attribute is not accessible. The attributes that we must check are those found in the where clause and within the print block named trips, which in this case are the trip description attributes included in trip and reservation date included in reservation. In the table diagram, we can clearly see that from reservation trip, we access a single record of the trip table and a single record of reservation. Therefore, Genexus must access those two tables every time it iterates in the forEach command. So, which records of the base table will the forEach command work with? With those that comply with the following. When going to the reservation table to evaluate the reservation date value, it's greater than or equal to the value of the reservation date variable received in a parameter. Also, the customer ID value must also match the value directly received through a parameter in that attribute. Remember that to receive in an attribute is to determine that this attribute will be instantiated. In other words, whenever that attribute is used anywhere, it'll be used with the value received when the object was invoked. Since the forEach command being examined already accesses the reservation table containing it, an automatic filter will be applied for that value of customer ID. It's important to clarify the following. The fact that the attribute received in the parm rule belongs to the extended table of the forEach command does not make it automatically apply as a filter. For this to happen, the forEach command must access that particular table of the extended table to perform an action. Okay, think about what happens with the nested forEach command. Its base table will clearly be the one associated with the phone level of the tourist guide transaction. The following question is, does it establish implicit filters for the information it'll use? Yes, it'll show the phones of each tour guide. Why? Genexus looks for a relationship between the extended table of the external forEach command and the base table of the nested forEach command. It's another way of looking for a one-to-n relationship, although in this case, it's an indirect one. If each reservation trip has a tourist guide ID, and in the table to be navigated, there's also a tourist guide ID, then Genexus understands that they'll be the same due to the relationship between them. That's why it'll make a join. In the next few videos, we'll continue to learn more about the forEach command.